we have another example here. This one's a little bit different. So here we are interested in testing whether the mean age at onset of anorexia nervosa in young people has been decreasing. Assume that the previous mean age at onset was 15 years old. Data was gathered from 20 young people who were admitted for the eating disorder. Assuming the sampling distribution is normally distributed, test this with a level of significance of 0.05. So if I look at the paragraph of information given to me, I can see that we are interested in testing if it's decreasing. The previous mean age was 15. We have a sample of 20 people, normally distributed, and a level of significance of 0.05. So if I write down off to the side here, mu, x bar, s, n, and alpha, mu is 15, n is 20, and alpha is 0.05. What is not given to me in the initial paragraph is x bar and s. However, what I am given is the data set for the 20 young people. I have the ages of the 20 people in the data set. So what I can do is I can go and find these. Just like I would any other data set. So if I take my data and I plug it into a spreadsheet and I calculate the mean and the standard deviation, the mean is 14.3. The standard deviation, I want to make sure I look at S because it's a sample, is 1.4903. The more decimals we give on the standard deviation, the more accurate our final answer is going to be. So I went and found these numbers ahead of time using Excel. And I calculated the mean and the sample standard deviation. So now that I have those, I'm going to go ahead and write out my null and alternative, which I could have done the null and alternative before I found those. So HO and HA. So the previous mean was equal to 15. And we want to see if the mean is decreasing, so going down from 15. So step 2 is to calculate our test statistic. Our formula is T equals X bar minus mu divided by S over the square root of N. X bar we calculated to be 14.3 minus 15 divided by 1.4903 divided by the square root of 20. Throw parentheses around the top and the bottom so we can do this all at once. And we minimize rounding error. So I get negative 2.101 when I round that. So then our p-value, now we're going to use t dot dist. There's nothing after the t dot dist when we have a less than, a left-tailed test. We're going to do the t, our degrees of freedom, and then we have to put the true in here. So degrees of freedom, reminder, is n minus 1. And we're putting the true in because we're telling Excel that we want it to calculate everything to the left, not just this individual t value at this one spot, because that wouldn't really make any sense. So if I draw the picture, we are down here somewhere. That might be a little too far. This is our t-score. If we didn't put true, if we put false, it would calculate just this value, which would be so small, and that's not what we want. We want the probability of being at this t-score, this value, or even further away. So that's why we need the true. We don't need the true with the other t.dists because it's assumed from Excel that we want a shaded region, not just an individual value. So for this one, t.dist negative 2.101. Our degrees of freedom is 19. And then true. So let's go ahead and pull up Excel. Equals t.dist negative 2.101, comma 19, comma true. .0246. So that's the probability of being at that value or further away to the left. So is that probability too small? Is that too unlikely? Which would mean that our results are significant. Is 0.0256 0.46 less than 0.05. Yes, it is. Since our P is low, we are going to reject the null hypothesis. And then we can write out our interpretation. So there is sufficient evidence to conclude that the mean age of onset of anorexia nervosa is decreasing from the previous mean of 15 years old. And this is an example that I really like doing because it allows me to talk about one of the big implications of this test. So we've done this hypothesis test. We get to these results. Now what do we do with it? Well, in this case, if we are doing this test for a company that is trying to promote healthy eating habits and body positivity and healthy lifestyles, and they have been focusing on going to the high schools to do their work. The results of this would suggest that they should also be targeting the middle schools because the mean age, the middle age, is actually less than 15. So that suggests that if the mean is under 15, 50% roughly of the young people are starting to have anorexia symptoms before the age of 15. Even before that, because now the mean age is under 15. And so if they wait until the students are in the high school, they are missing a large proportion of the students. So the results from this could tell this group, hey, we're doing a great job targeting the high schools, but we need to also focus our attention on the middle schools. And we need to be going to the middle schools and promoting these programs that we have, or whatever it might be. Because they're missing a large demographic that they need to be hitting in the middle schools. So this kind of gives you a little bit of an idea on what happens after the test with this one. Oh great, we did the test, we rejected, woohoo, what does this mean? Well, it's not actually a woohoo in this case. But it can be used to make really good impacts later on. So that is the last example of hypothesis testing for means.